right, it's time to start talking about probably one of the most remembered theorems, mathematical theorems in the wider community from their schooling, at least in my experience, and that's Pythagoras Theorem. And what I mean by that is I can be talking to a complete stranger and they'll discover that I'm a teacher, and often I get asked that question of, do you still cover Pythagoras Theorem at schooling? And I'm like, amongst many other things, yes, it's still part of the curriculum. They're like, I remember Pythagoras Theorem. And I'm like, fantastic. So what is Pythagoras Theorem? Well, Pythagoras Theorem is a right-angled triangle theorem. And it's really important that it is only to do, based around right-angled triangles. So what the theorem basically says is if we have any sized right-angled triangle, and you can create any sized right-angled triangle, for the sake of this, I'm going to talk about probably one of the most remembered and recognized right-angled triangles out there. But if you've got a right-angled triangle, and I'm going to talk about the right-angled triangle, the 3, 4, 5 triangle. All right, and what I mean by that is this side length's 3 units, the bottom side length's 4 units, and then this side length here is 5 units. You can't create a non-right-angled triangle with these 3 side lengths. All right, so this will form a right-angled triangle for you. If you've got any size right-angled triangle though, what Pythagoras Theorem says is if I create a square out of each side, so let's take the longest side here, all right, and the longest side happens to be known as the hypotenuse, we'll get to that later, but we'll take the hypotenuse and we'll form a square out of it. And then we'll do the same with the other 2 sides, so this shorter side here. These are probably going to be pretty dodgy looking squares, but it'll demonstrate my point. We'll use blue for the 4. So you grab each side here and form a square out of it. What Pythagoras Theorem says is if this is a right-angled triangle, and we know that this particular example is, but if this is a right-angled triangle, the area of the longest side square, so this area of this square just inside here, will be the same as the area of these 2 shorter squares added together. So you sit there and go, okay, well, how would I calculate the area of this? Well, the area is going to be, because it's a square, it's going to be one side times by itself. So this side length's 5, this side length's 5, so it's going to be 5 squared. Now 5 times 5 is, we'll just put it here, so it's 5 squared, which equals 25. So 25 units, or square units, I should say. What that's trying to say here is it's going to be equal to the 2 shorter squares added together. So if we looked at the area of this is going to be 3 squared, because each side length is 3, which is going to be 9. And then for this other shorter square down here as well, this is going to be 4 squared, which is going to be 16 square units. All right, so I haven't got units written down here, but for the sake of this, we'll just keep going. Now, what it's saying is if we did this, that area of the larger square, so that 25, should be equal to the area of the 2 shorter squares added together. So that 3 squared, which is 9, added with the 4 squared, which is 16. And you can see here that 9 plus 16 does equal 25. So this here shows, well, is an example of, it's certainly not a proof, but it's a convincing exercise to show that this is a right-angled triangle. And that's essentially what Pythagoras Theorem is saying, is the area of this longest square just in here is going to be equal to the area of the 2 squares on the shorter sides added together. All right, so we generalize this to be a rule here. So because this works for every right-angled triangle, like I said, this is not a proof, but it does work for every right-angled triangle. That's what we're sort of saying here, is just believe me on that. We can generalize this. We can sit there and go, okay, instead of saying that we've got 3, 4, and 5 as our side lengths, let's call the longest side C. And for the sake of this, I'm also going to say that this longest side just in here is known as the hypotenuse, because that's something that's really, really important to get to know the language. So it's the hypotenuse. which is the longest side. You'll also notice with every right angle triangle that the longest side will always be opposite the right angle. So you can see that the right angle is between the two shorter sides. With all right angle triangles, that'll always occur. The right angle will always be between the two shorter sides, and the longest side will be always opposite it. But what Pythagoras Theorem is saying more generally speaking is we call this A. So A is just representing whatever the length that is. And we use blue here. B is just representing this. When we work out the square, the area of the square that this creates, so that's going to be C times itself, so C squared. It should be equal to the area of the two shorter sides squared and added together. So that'll be A squared plus B squared. And that, in essence, is what Pythagoras Theorem is this formula just in here. All right, and we can use this formula to do several things, which is what we're going to look at after this. But essentially what Pythagoras Theorem is it's just showing here that the area of the longer side, known as the hypotenuse, is going to be the equivalent of the area of the two shorter sides added together. All right, so you might sit there and go, okay, well, what are the uses for this? Well, since we can get a formula out of it, there's two main uses that we can do. We can use this formula to, if we know two pieces of information, so if we know two side lengths and we know it's a right angle triangle, that's also important. We can use this formula to find the other side length, the other unknown side length. All right. And the other use for it is if we know all three side lengths of a triangle, we can actually go about finding what the, determining whether or not it is going to be a right angle triangle. So they're the two things that we're going to look at in the next videos.